Before getting into the header data, I first want to cover some terms used that may seem unfamiliar to you. While there is virtually no mention of the terms vector, table, and matrix in the Basic09 reference manuals, Microware did define them in the OS 9 reference manual. Version 2.4 is the one I was able to look at back in the early 1990s. Vector is the name Microware gave to one-dimensional arrays. Table is what they named two-dimensional arrays, and matrix is what they named three-dimensional arrays. Before I knew what Microware named those two tables after the I-Code area, I named them DSAT, Data Storage Allocation Table, and VDT, Variable Declaration Table. Microware named them Description Area and Symbol Table, respectively. Throughout this video series, and throughout the web document, I will use the above terms where necessary, referring to the two tables by the Microware nomenclature as needed. Module Format. Basic09 modules use the following format for every procedure. Each module begins with a module header. Following the header is the I-code, or instruction, area. This is where all of the instructions are stored in postfix notation. This will be covered in the I-code area video. The bottom of the module contains two tables, separated by a 3-byte structure, which I call the total program variables, and will be covered in the symbol table video. The first table is called the description area, which I named the DSAT. This table contains the shape data for all string, array, and record variables, and the associated type data related to the record variables. The second table is the symbol table, which I named the VDT. This table contains the variable references for the variables used by the procedure. The last section of the module is the CRC, cyclic redundancy check. This isn't calculated until the module is packed and doesn't occur in unpacked modules. Standard OS 9 module header. The standard OS 9 module header uses the same fields as Basic09, not including the optional header extensions between the header parity byte and the module name string. Also, the module name string in object code modules can occur anywhere in the module, not just at the end of the standard header fields. The Basic09 module header. The Basic09 module header is comprised of 17 fields. The first 6 fields are standard module header fields. Following that are the 10 optional header extension fields which occur after the header parity field and before the module name string. Unlike object code modules, the name string in Basic09 modules will always occur immediately after the module name length byte field. The Basic09 header fields. Module header space, or sync bytes. This field always contains the value hexadecimal 87 CD. This value is used to allow OS 9 to place the module in the module directory, accessible to any processes that use it. Total procedure block size. This is the size of the module, including the header and CRC value. The module size isn't set and the CRC isn't calculated until the module is packed. Module name offset. This field contains the address, relative to the beginning of the module, where the module name string is stored in the module. Module type and language. The module type is always hexadecimal 22. 20 means subroutine module and 2 means Basic09 I-Code. Module attributes and revision. The module attributes is always hexadecimal 81. 80 means the module is a reentrant, relocatable object, and the revision is 1. I'm not sure if the revision number is changeable as I've never tried to change it. Module header parity. This value is not set until the module is packed. I am still not certain how the header parity is calculated, or how many of the preceding fields are used in its calculation. Optional header extensions. I-code area address. This is the offset, relative to the beginning of the module, to the beginning of the I-code, or instruction area, of the module. This is where all of the instruction statements of the procedure are stored. RunB, the runtime module of Basic09, executes each instruction contained in this section of the module. Runtime variable storage size. This is the total space requirement for the data memory allocation of the procedure. Symbol table address. This is the offset, relative to the beginning of the module, to the beginning of the symbol table, or VDT. Description area address. This is the offset, relative to the beginning of the module, to the beginning of the description area, or DSAT. Procedure Link Storage Offset. This is the offset to where in the data memory allocation the named subroutines are stored. The named subroutines in the symbol table also point to this area of data memory, with each entry pointing to the location of that subroutine's address in the module directory. First data statement address. This is the offset, relative to the beginning of the I-code area, of the first node of the first data statement in the module, if there are any. If there are no data statements, this value is 0. First executable statement address. This is the offset, relative to the beginning of the I-code area, of the first statement that is executable. In packed modules, this value is 0 and points to the beginning of the I-code area. In unpacked modules, due to the inclusion of comments and dimension statements before the first executable statement, this value will always be greater than 0. Procedure status. While this byte can have different values in unpacked modules, in packed modules it will always have the value hexadecimal 80. In unpacked modules, it will contain error flags for syntax errors and compiler errors, and possibly other uses. Procedure name size. This byte contains the value of the length of the module name. As an example, if the module name is test, this byte will contain the value for procedure name. This is the module name. As with all OS 9 modules, the name will have the high bit set on the last character of the name string. Basic09 doesn't use this, instead using the name length byte to determine the length of the name string. Edition number. This field is actually the first byte of the first statement in the I-code area. Basic09 doesn't use this field, and it only shows up when you use ident to identify the module. This concludes the description of the Basic09 module header. In the next video we will discuss the I-code area. Thanks for watching, and I'll see you in the next video. Please press that thumbs up if you like the video and believe you have gained something from it.